A car is traveling at a constant speed of 33.5 meters per second on a highway. I'm going to call that, actually, I'm going to wait on assigning variables until I read the whole problem. At the instant this car passes an entrance ramp, a second car enters the highway from the ramp. The second car starts from rest and has a constant acceleration. What acceleration must it maintain so that the two cars meet for the first time at the next exit which is 2.54 kilometers away? So I need a picture. So this is going to be our starting point. And I'm going to call this over here our final. So this is where we first pass each other. This is going to be me. This circles me. And then this is going to be the other car. So I just want you guys to imagine what this would look like in between the start and the finish. So we start at the same point, but and we want to get to the final at the exact same time, right? But in between, we're not moving at the same speed, right? We're probably going to be, when we're right here, the other car is probably going to be still over here because they are starting from rest and they're trying to accelerate, trying to catch up, right? So I'm going to rate this as the velocity of me. And is our velocity the same for the entire time? Yeah, we aren't accelerating. They didn't say that in the problem. So we are traveling at a constant speed the entire time. Now, on the other hand, this car, I'm going to call this mm, V, VP initial. Because usually, like, isn't it weird? Like, only a police car would um, enter a highway starting from rest, you know? They're like watching people. So I'm going to just call this like a police car. Kind of makes more sense that way. So this is the initial speed of the police car, which was 0, right? And then, of course, it's going to have a final velocity, VP final. And what causes that change in acceleration from 0 to something, which we don't know, it's going to be the acceleration. But we don't know the acceleration, but that's what we're asked to find. So we have to do that. Let me put in other details that we have. So the distance, let me write that over here. The distance from the start to the finish, that's going to be our displacement. We are told that that is 2.54 kilometers. What else do we know? I mean, maybe not. Let me write my step 2 here to organize. So velocity of me, that was 33.5 meters per second. And our displacement, overall distance we travel is 2.54 kilometers. Now, I want you guys to notice that this is in kilometers. You generally are not using kilometers, we are using meters, right? Like this velocity, it's in meters per second, not kilometers per second. So I need to change this into meters. So I will do that right now. 2.54 kilometers. 1 kilometer is 1,000 meters. So overall, our displacement is going to be 2,540 meters. Okay, now onto the police car, the VP initial. Well, they started at rest, right? So 0. Maybe that's all we know. That was our knowns. So I'm going to write our unknowns over here. We don't know the final velocity of the police car. We also don't know the acceleration of the police car. I'm going to say that's AP. And it's not, this term hasn't come up in this problem, but we can also say that we don't know how much time this whole process has been taking place for. We don't know the time. So there's a lot we don't know. But let's look at our equations now. We're not dealing with forces. We're just dealing with kinematics. So I'm going to write down our kinematics equations. Okay, so we got that. And now I think I want to start thinking about how to solve this because it's got a twist. So we want to find the acceleration of the police car. So let's try and evaluate these three equations with respect to the police car. Don't confuse any of the variables and values of us when we evaluate. We just want to evaluate the police car's kinematics of motion. So the final velocity of the police car, we don't know. Okay, we don't know that. The initial velocity of the police car, we do know it was 0. A, that's what we're looking for, right? Let me just circle all the A's in here. That's what we are ultimately trying to find, but we don't know how long it took. So it's kind of like a meh, you know? Okay, displacement, we do know that. We know how long they traveled. The initial, we do know time. We don't know how long this took. Okay, so far it looks like we can't use 1 or 2. Let's look at number 3. V final. We don't know the final velocity of the police car. So it seems like none of these equations are going to work because there's too many unknown variables, values for all of the equations. So you're kind of like, we're stumped. We don't know what to do. So that's when we have to start thinking about more clues from the hour movement. We know our velocity and we know the distance we traveled. So we know that if we want to look at these equations for us, let me actually rewrite these. So this is going to be for like the police, and then this is going to be us evaluating the equations with respect to our motion. Okay, so V final, we do know that we were moving at a constant velocity. So we do know V final, it's the same as V initial. Were we accelerating? No. So wait, hold on. I should clarify what we are exactly looking for. Okay, that means we have to go back up here. We want to find the acceleration to, hold on. To find the acceleration, we need to find other values, whether that be V final or time. The only variable that connects the police car and us between the v final and time, it's going to be time, right? We aren't affected. We're completely unrelated to the final velocity of the police car, but the time is the same for us and the police car, right? That's a common number, whatever it's going to be. That's something we share. So knowing that, I think I want to solve for the time that passes, how long it took from us to go from start to finish. So that's what I'm going to try to look for in our kinematics, some way to find time. So we want to find time, which means I'm not even going to look at number 3, right? Okay. We do know v final, it's the same as v initial. V initial, acceleration. Are we accelerating? No, we're not accelerating. We had no change in velocity at all. If we're trying to find t, but it's multiplied by 0, we're not going to be able to find t, right? So I don't think we can use number 1 either. So let me look at number 2. So the displacement, we do know how much we traveled. We do know v initial, t, that's what we're looking for. And same thing over here. Acceleration is going to be 0. So this t is going to be canceled out, but we have t over here. So I think I can use this segment, right? And I've explained this in another video, but you know, we kind of all generally know that velocity is distance over time. These are the same thing. These are just like rearranged. The distance or displacement, that's going to be x, right? So if I were to divide t on both sides with this equation, it just looked like vi x over t. That's the same thing as, see, these are the same thing. So you could have, if you knew we had to get time, you could have just kind of used this and just kind of solved it. But I wanted to go through the steps with you guys. So we now want to find the overall time it took for us and the police car to go from point, well, start to finish. So let's do that. We were going to use x equals, I want to find time. So x equals v initial times the time for, in respect to us, okay, not the police car. So the overall distance that we travel is 2,540 meters. Well, actually, I'm going to just divide both sides by t and then flip it so it looks like this. And then I'm going to put in my numbers, 2,540 over v initial is 33.5. Oops. 33.5. I generally don't like to calculate until we're at the very, very end, but this is a case where you kind of have to. So 2,540 divided by 33.5 gives me 75.82. It's a long number. I'm just going to cut it off at here. Seconds. So now we know how long it took for not only us, but also the police car to go from start to finish. I can now use this value to plug into one of the kinematics of the police car. So let's go back here. We now know time. So I'm going to look at number 1, v final. We still don't know v final, and we're looking for a, so we can't use number 1. We do know displacement. We do know the initial, the time, and we want to know the acceleration. So acceleration is the only value that we don't know in this equation, which tells me that we can solve for a. So I'm going to rewrite that up here. Should I go down or side? I'm going to go side. So I'm going to say find acceleration of the police. So V, that's like this is the general formula, right? Now I'm gonna rewrite it like the V initial, that was the VP initial, right? T plus 1/2 AT squared. Oh, A should also say AP. Okay. If you watch my videos, you know I always like to plug in values at the end, but this might be a case where we should just kind of plug in the numbers right now. So I'm going to do that. The overall distance we traveled was 2,000, 2540. 2540. Okay. And the initial velocity of the police was 0, right? Time was 75.82. It's going to become 0, but I'm still going to write it all out. 1/2 acceleration, that's what we want to find. And the time, 75.82. So now it's going to be just algebra, trying to find A. So I'm going to just start doing that. This is all just going to become 0, so I'm not going to even bother writing it. 1/2 A, I'm not going to square this yet because it's going to become a big yucky number. I want to isolate A, so I think I'm going to multiply both sides by 2. See how that'll go. So if I multiply 2,500 and did I write 48? Oops, that's not correct. That should be 0. Oh, I'm glad I catch that. 40 times 2. That's gonna give us 5,080. A 75.82 squared. And now I am going to divide both sides by 75.82 squared and flip it. So I'm going to rewrite that. And then let's put that in our calculator. Okay, so I got 0.8836 meters per second squared. Does that sound right? I don't know. It's kind of hard to tell. There are ways to check your answers. Should I do that? If you wanted to check your answer, make it so, try to plug all your values into this equation, but try to solve for x. We know the answer, but let's just like put in the values for T and A for the police car. And if you get 2,540, that means you are correct. That's just one way to check it. I'm not going to do that right now. If you want to, go ahead and do that. But so that is how you solve this problem.